Okay, so you wanted to understand how to solve this particular equation using the inverse logarithm. And we use the inverse logarithm because we're solving for an unknown that's in the exponent. In this case, I made the unknown t. Now remember, we have to have only one unknown, so I made randomly made the a 10,000, and I left the other values the same. First step is you want to simplify what's in parentheses. You want to simplify that base here, 1 plus 0.06 divided by 12. And when you compute that, you get 1.005. So I'm going to rewrite this equation with a simplified base. So that's 1.005 to the power of 12t. Then to apply the logarithmic function, I want to isolate the exponential function. I want to isolate the base with the exponent. So that means I need to undo the times by 8,000. To undo times by 8,000, I divide both sides by 8,000. Divide this side by 8,000. And divide this side by 8,000. That leaves us with 1.005 to the power of 12t, because this cancels out. Anything over itself is 1. And over here, these zeros cancel, and this reduces to 5 over 4 equals 1.005 to the power of 12t. Now you see that we have the exponential function where this value, which is by itself, is our y value. That's our range. And this value is the x value. That's the domain. And here's the base. And you know by the definition of logarithms that to find the inverse function, we keep the bases the same, but the domain and range are swapped. So you see here, for the exponential function, x is the exponent, but then x is alone for the logarithmic function, so x becomes then the range. And for the exponential function, the y is alone, but then that same value becomes the domain for the logarithmic function. Now y is not alone for the logarithmic function. So we apply that same principle to this problem. We keep the base, we write log base 1.005 of, now the y, which was alone, is now not going to be alone. The y is 5/4, it's going to go here. And the x, which is in the exponent, the domain, is now going to be alone. It's going to be the range for the logarithmic function. So now you see what we accomplished. We got the t out of the exponent position so that we can now solve for t. To solve for t, we're going to have to divide both sides by 12. So I'll just divide it out here to show you. I'm going to divide it here, and we're going to divide over here by 12. So then t is equal to a 12th, you can write it this way, a 12th of log base 1.005 of 5/4. Now this simplifies to t is equal to 1/12 log of log base 1.005 of, this is our domain, 1.25. 5 divided by 4 is 1.25. Now, log base 1.005 is not on your calculator. We only have ln, which is log base e, or just log, which is log base 10. So we need to use the change of base formula, which says that if a, b, and c are real numbers, then log base b of a is equal to log base c of a divided by log base c of b. We can make c either 10 or e. And that way we can use the calculator to compute the logarithm for which we cannot use the calculator, a logarithm that does not have base e or base 10. So in this case, log 1/12 log of 1.25 to base 1.005 would become 1/12 log of, I'm going to make it log base 10, so it's, I always remember it's log of the big number, and the big number is 1.25, over the log of the little number, which is the base of the original log. The base of this log is now 10. I'm going to use log base 10. And then I'm going to compute this on the calculator because I have log base 10 on the calculator. So then, computing this on the calculator, log on the calculator 1.25, and you want to be sure to close this second set of parentheses here that appear in the calculator. Close this set of parentheses. I did that division. I got 44.74. Divide 44.74 by 12, and I get approximately 3.7 years. Time is 3.7 years. So to summarize, we simplified the equation. We got the exponential function by itself. We converted the exponential function to a logarithmic function using the definition of logarithms, where you keep the base and you swap the output and input values. Then we did some simplification of the operations of the numbers. Then we applied the change of base formula to convert the logarithm to a base 10 logarithm so that we could use the calculator. And then we computed our answer using the calculator.